Hi, Bob Carrier, C&K Plastics, second generation owner of C&K Plastics, located in Metuchen, New Jersey, and Conyers, Georgia. I want to talk to you today predominantly about tooling and why we almost always go with aluminum temperature controlled tools. Now let me give you a little overview of the whole process of thermoforming real quick. Everything in the plastic processing starts with resin. Resin is important from a thermoforming standpoint. You pick out the parameters you'd like for the job, whether you need weatherable, high impact, low impact, inexpensive, ability to color, abrasive resistance, UL rated, RF transmission, etc., etc., etc. But that's not all we're looking for. What we're looking for is a very consistent melt flow. What we need this plastic to be able to do is when an extruder makes it into a sheet, it's got to have some stiffness to it so that the sheet can get formed in a very low stress environment. Now there's always going to be stress because you're melting the resin and you're squeezing it out of a barrel into a sheet die that is manipulating the material out to a wide, sometimes 8-foot wide sheet, and then extruding it down through a series of rollers that cool it and emboss it sometimes. As you can see in this sheet, that's a grain pattern on it. That comes out of the sheet, and when we thermoform, we can keep that grain in the process. So what's important is that we have a consistent melt flow, not only for the sheet extruder to be able to extrude a consistent sheet, but when we take this sheet and we irradiate it with IR heaters on the top and the bottom, that we want that melt flow to be consistent so that it sags the same every time. What I mean by sag is that when this sheet goes below its glass transition point, it's no longer a solid. It's somewhere between a solid and a liquid, and it gets to be like taffy. And we want a consistent bag or a consistent bubble that is going to process the same way all the time. That comes to number 2 on the list. Number 2 is the processing equipment. It's very, very important to have good microprocessor controlled heaters that heat up the profile of your sheet. You'll never get a good thermoform part unless you make sure you're heating the core, which means you need to be able to measure the surface temperature of the sheet and know what the soak is of the radiation into the middle of that sheet. Now, heating an 1/8 inch piece of material or a 1 inch piece of material is completely different. We do some 1 inch material, but you cannot heat that with IR heaters. You have to heat it in a convection oven and then thermoform it. Because again, it's all about the core temperature. You have to have very little gradient through this temperature. And plastic is not conductive of thermal energy, so you need to make sure that the radiation penetrates specifically the same way every time, every shot, in order to get a successful part. Now, we put all of this effort into making microprocessor automated production equipment. We at C&K Plastics have lots of machines. We have zero sag machines that are shuttle machines. We have lots of single station machines. But what we predominantly use is automatic load and unload rotaries. Now, a rotary, what's interesting about a rotary is while you're loading and unloading a part, you're heating the part. While you're heating the part, you're molding and cooling a part. So the process takes place all three at the same time. As far as a shuttle machine, you heat the part. When it's heated at the temperature, you shuttle it to a molding station, you mold the part, then you cool the part, and then you demold the part, and then you reload the part. If it takes 3-minute cycle, that's 3 plus 3 plus 1, that's a 7-minute cycle. On a rotary, it's going to be a 3-minute cycle. So if you want to make a part every 3 minutes, tooling is of utmost importance. So you have microprocessor controlled heaters. You also have various different materials. A lot of times you'll go with assembly crystalline materials, all the olefins, the TPO, the polyethylene, the polypropylene, and you'll run sometimes utility material where the melt flow varies a little bit. So it's really important that you have other process controls within your system. You need to have pyrometers that measure the surface temperature of the material, and you can cycle off the temperature off the pyrometer. And a lot of times you use a sag eye. So whenever the sag of the bag of the glass transition point of the material hits that sag eye, it automatically rotates, and that's how we're able to run, aluminized materials and some, well, let's call it what it is, some wide spec polyolefins materials.